Imagine looking at the human body the way a physicist studies a machine, not a perfect machine carefully designed by engineers, but something far stranger. A machine built slowly over millions of years through countless small changes. Every bone, every muscle, every tendon in your body is the result of tiny adjustments made by evolution. None of these parts were planned in advance. They were simply the variations that happened to work well enough for survival, repeated over unimaginable stretches of time. When physicists examine a machine, they often ask a simple question: what is this system optimized to do? A rocket engine is optimized to produce enormous thrust for a short time. A car engine is optimized for controlled power over long distances. Every machine reveals its purpose through the way it is built. If we apply the same idea to the human body, something interesting begins to appear. Our bodies do not look like they were built for extreme power. They do not resemble the bodies of animals designed for explosive speed or overwhelming strength. A gorilla can easily outlift a human. A cheetah can outrun us effortlessly. Even many ordinary animals are far more powerful or faster than we are. Yet humans survived, spread across the planet, and eventually became the dominant species on Earth. So the question becomes, what exactly is the human body designed to do? The answer might be surprisingly simple. The human body appears to be designed primarily for one activity: steady, continuous movement through the environment. In simpler terms, walking. That might sound almost too ordinary to be important. Walking is so common that we rarely think about it. It feels effortless, automatic, and even trivial. In modern culture, walking is often treated as the lowest form of exercise. People assume that real fitness requires intense effort, heavy weights, high-speed running, or exhausting workouts. But when we step back and look at the body from the perspective of physics and evolution, walking begins to look very different. Instead of being a minor activity, it begins to look like the central operating mode of the entire human system. Imagine the world long before cities, roads, and vehicles existed. Early humans lived in environments where survival required constant movement. Food was not stored in refrigerators. Water did not come from taps. Shelter was not permanent. Every basic need required traveling through the landscape. Humans walked to find fruit and plants. They walked to search for animals to hunt. They walked to locate water sources. They walked to follow migrating herds. They walked to explore unfamiliar territories and avoid danger. Movement was not a special activity added to life. It was simply part of living. Anthropologists studying traditional hunter-gatherer societies estimate that early humans often traveled 10 to 20 kilometers per day. That distance was not considered exercise. It was simply the normal pattern of daily life. And this detail is important. Those humans were not sprinting all day. They were not performing intense bursts of effort every hour. Most of their movement was slow, steady, and continuous. They walked across landscapes for long periods without exhausting themselves. If you observe the human body carefully, this pattern begins to make sense. Our muscles are not built for maximum force. Our bones are not built for short, explosive actions. Instead, the entire system seems balanced around endurance and efficiency. The body is like a machine designed to move through space for long periods while using as little energy as possible. Every step uses gravity, momentum, and elastic tendons to recycle energy rather than constantly creating new effort. In other words, walking may not just be something humans do. It may be the activity around which the entire structure of the human body quietly evolved. To understand why walking might be so central to the human body, it helps to imagine a world where the idea of exercise simply does not exist. Today, people schedule workouts, they go to gyms, follow fitness programs, and track their activity with devices and apps. Movement has become something we add artificially into our lives because modern life often removes it. But for most of human history, exercise was never a separate activity. It was simply the natural consequence of staying alive. Imagine a human living 200,000 years ago. There are no cities, no supermarkets, no vehicles, and no technology that reduces physical effort. The environment itself determines how the day unfolds. If the person wants food, they must travel to find it. If they need water, they must walk to reach it. If the seasons change and resources disappear, they must move across the land in search of better conditions. Movement is constant, but it is not extreme. The human does not sprint through the landscape all day. That would quickly exhaust energy reserves. Instead, the human moves at a pace that can be sustained for hours. This pace is walking. Anthropologists studying modern hunter-gatherer societies have observed patterns that likely resemble the lives of early humans. In many of these communities, people regularly travel long distances each day while gathering plants, tracking animals, or moving between camps. The distances can range from 10 kilometers to sometimes even 20 kilometers or more. But what is striking is how this movement occurs. It is steady and consistent rather than intense. People move through the environment at a pace that allows them to continue for long periods without collapse. The body settles into a rhythm that conserves energy while still covering large distances. This pattern reveals something about how evolution works. Evolution is not concerned with producing the strongest or fastest organism possible. It is concerned with survival under limited resources. Every calorie spent by the body must eventually be replaced by food, and food is not always guaranteed. Because of this, evolution strongly favors efficiency. An organism that can move across large distances while spending less energy has a significant advantage. It can search wider areas for food, escape danger more effectively, and survive periods when resources are scarce. Walking turns out to be one of the most energy-efficient forms of movement that a human can perform. Running uses far more energy because the body repeatedly lifts itself off the ground and absorbs heavy impact forces with every stride. Sprinting uses even more energy, exhausting muscles and oxygen supplies very quickly. Walking, by contrast, allows the body to remain in contact with the ground while transferring energy smoothly from one step to the next. The motion is stable and controlled, allowing the body to travel great distances without rapidly draining its energy reserves. This means a walking human can explore the environment for hours while still conserving enough strength to react to unexpected events like climbing, carrying, or brief bursts of running. When you think about survival in a wild landscape, this ability becomes extremely valuable. The human who can travel the farthest while using the least energy gains access to more food sources, more water locations, and more opportunities to adapt to changing conditions. Over thousands of generations, small advantages like this shape the body. Muscles, bones, joints, and even the nervous system gradually adjust to support the type of movement that happens most often. And for humans, that movement appears to have been the quiet, steady act of walking across the earth. If we look more closely at walking itself, something fascinating appears when we analyze it using physics. At first glance, walking seems simple. One foot moves forward, then the other, and the body moves along the ground. But underneath that simple motion is a very elegant mechanical system. When a human walks, the body behaves in a way that physicists often describe as similar to an inverted pendulum. A normal pendulum, like the swinging weight in a clock, hangs below a pivot point and swings back and forth under the influence of gravity. In walking, something similar happens, except the body moves above the pivot point instead of below it. When your foot touches the ground, it becomes the pivot point. Your leg acts like a rigid rod supporting your body. As you move forward, your body slowly rises and passes over that leg before falling slightly into the next step. Then the other leg becomes the pivot, and the process repeats. This motion is surprisingly efficient because gravity is doing part of the work. Instead of forcing the body forward entirely through muscular effort, the body allows gravity and momentum to help move it along. Each step is partly powered by the natural falling motion of the body as it shifts weight from one leg to the other. But the efficiency does not stop there. The human body also uses elastic energy stored in tendons and connective tissues. One of the most important structures involved in this process is the Achilles tendon, which connects the calf muscles to the heel. When your foot strikes the ground during a step, the Achilles tendon stretches slightly under the load of your body weight. This stretching stores energy in the same way a compressed spring stores energy. As the body moves forward and the foot pushes off the ground, that stored energy is released, helping propel the body into the next step. because of this mechanism. Not all of the energy required for walking has to come from fresh muscle contractions. Some of it is recycled from the previous step. The body captures part of the mechanical energy and reuses it in the next movement. This energy recycling is one of the reasons walking is so economical. A person can walk for hours without feeling the extreme fatigue that would appear after only a few minutes of sprinting. The system is designed to reduce wasted effort and distribute work across multiple muscles, tendons, and joints. Another important feature of walking is stability. When humans walk, at least one foot is usually in contact with the ground. This creates a stable base that prevents the body from losing balance easily. Running, on the other hand, includes moments when both feet are off the ground. Those airborne moments require stronger impacts when the body lands again, which increases energy costs and mechanical stress. Walking avoids many of those stresses by maintaining continuous support. The body moves smoothly across the ground with controlled shifts in weight rather than violent impacts. From a physics perspective, this is a beautifully balanced system. Gravity, momentum, and elasticity work together to reduce the amount of energy the muscles must produce. The body becomes a moving structure that cooperates with physical forces rather than constantly fighting against them. This efficiency may seem like a small detail, but over long periods it becomes incredibly important. If early humans traveled many kilometers every day, even a small improvement in energy efficiency could determine whether someone finished the day exhausted or still capable of responding to danger. The structure of walking allows humans to cover large distances while conserving precious energy, and over many generations, the body appears to have adapted more and more towards supporting the simple, steady form of movement that carries us quietly across the world one step at a time. If walking truly plays such a central role in human life, we should expect to see its influence written directly into the structure of the human body. Evolution rarely leaves clear labels explaining why something exists, but it leaves clues in anatomy. Bones, joints, and muscles often reveal the kinds of movements an organism performs most frequently. When scientists compare the human skeleton with the skeletons of other animals, they immediately notice something unusual. Humans are built for upright movement on two legs. This is called bipedalism. Most mammals move using four limbs, keeping their bodies roughly horizontal to the ground. Their spines extend like a bridge between the front and back legs, distributing weight across 4 points of support. Humans, however, stand vertically. Our entire body balances over two legs. This may seem ordinary because we experience it every day, but from an evolutionary perspective, it is a very rare and dramatic design change. One of the most important adaptations is the shape of the pelvis. The human pelvis is shorter and wider than that of many other primates. This structure helps stabilize the body when standing upright and when shifting weight from one leg to the other during walking. Every time you take a step, your body briefly balances on a single leg. Without a stable pelvis and strong hip muscles, the body would tilt sideways and lose balance. The length of the human leg also plays an important role. Compared to body size, humans have relatively long legs. Long legs allow each step to cover more ground, which means fewer steps are needed to travel a given distance. Fewer steps mean less energy spent over time. This small advantage becomes very significant when someone travels many kilometers in a day. The human foot also contains remarkable features related to walking. Unlike the feet of many other primates, which are adapted for grasping branches, the human foot has a strong arch. This arch acts like a natural shock absorber and spring. When the foot touches the ground, the arch compresses slightly under the body's weight, storing energy and distributing pressure across the foot. As the body pushes forward into the next step, the arch releases some of that stored energy, helping propel the body ahead. In this way, the foot works together with tendons and muscles to make walking smoother and more efficient. Another subtle but important adaptation is found in the spine. The human spine forms a gentle S-shaped curve rather than a straight line. This curve helps position the body's center of mass directly above the hips and legs. When the center of mass is balanced properly, Less muscular effort is needed to remain upright. Imagine trying to balance a long stick vertically on your finger. If the stick leans too far forward or backward, you must constantly adjust to keep it from falling. But if it is balanced directly above the pivot point, maintaining stability becomes much easier. The curves in the spine help maintain this balance during both standing and walking. Perhaps the most important change that came with upright walking was the freeing of the hands. Once our ancestors no longer relied on their arms for locomotion, their hands became available for entirely different tasks. Hands could now carry food gathered from distant places. They could hold tools, shape objects, and manipulate the environment in ways other animals could not. This change may have been one of the turning points in human evolution. Walking upright did not just change how humans moved, it changed what humans could do. Carrying objects allowed early humans to transport resources back to their groups. Tool use allowed them to hunt, cut, and build more effectively. Over time, these abilities influenced brain development, social cooperation, and technological innovation. In a sense, the simple act of walking on two legs quietly transformed the entire trajectory of human history. So when we examine the skeleton carefully, it begins to look less like a general purpose structure and more like a system deeply tuned for upright, energy-efficient travel across long distances. Every step we take reflects that ancient design, shaped slowly across generations as humans moved steadily across landscapes in search of food, water, and opportunity. When people compare humans to other animals, the first thing they often notice is how physically unimpressive we appear. A human is not especially strong compared with many mammals. Even a chimpanzee, which is smaller than most humans, can produce far more raw strength. In terms of speed, humans also seem mediocre. Many animals can run faster, jump higher, and react more quickly. At first glance, this seems like a disadvantage. If survival depended only on power or speed, humans would struggle in a world full of stronger and faster creatures. Yet humans managed not only to survive, but to spread across nearly every environment on Earth. The explanation may lie in a different physical ability. Endurance. Endurance means the ability to continue moving or working for a long period without exhaustion. While humans may not be the fastest sprinters in the animal kingdom, we are remarkably capable of sustained movement over long distances. This ability becomes especially interesting when scientists look at how early humans hunted. There is a hunting method known as persistence hunting. Instead of chasing an animal in a short, intense burst, hunters simply follow it over long distances. The animal runs away at high speed, escaping quickly at first, but animals that rely on sprinting often use enormous energy during those bursts of speed. After a sprint, they must stop and rest while their bodies recover. The human hunter does something different. Rather than trying to outrun the animal, the hunter moves at a steady pace, following the animal's tracks. The pace may be a walk or a slow jog, but it continues for hours. Each time the animal stops to recover, the hunter approaches again, forcing it to run once more. Over time, this pattern repeats again and again. The animal sprints, the human keeps moving. Eventually, the animal begins to overheat or exhaust its energy reserves. Many animals cool their bodies primarily by panting, which becomes less effective while they are running. Humans, however, cool themselves in a different way. The human body is covered with sweat glands that release moisture across the skin. As the sweat evaporates, it removes heat from the body. This system allows humans to regulate temperature even during extended periods of movement. Because of this cooling system, humans can continue moving steadily even in warm environments where other animals begin to struggle with overheating. Over many hours, the advantage shifts. The animal that was faster at the beginning slowly becomes weaker as it spends energy in repeated sprints. The human, moving steadily and patiently, closes the distance again and again. Eventually, the animal may collapse from exhaustion. This hunting strategy does not rely on speed or strength, it relies on persistence. The human simply keeps moving longer than the animal can. What makes this strategy remarkable is how closely it connects with the idea of walking as a central human ability. Persistence hunting would be impossible if humans exhausted themselves quickly during movement. The strategy only works because the body can maintain a steady pace for very long periods without consuming energy too rapidly. Walking and slow running allow humans to cover enormous distances across landscapes. The body's cooling system, its long legs, its spring like tendons, and its efficient mechanics all support this type of movement. This does not mean early humans were constantly chasing animals for hours every day. Such hunts were likely rare and required cooperation between several individuals. But the physical ability that made such hunting possible reveals something important about the human body. Humans may not dominate through explosive physical power. Instead, our bodies appear to be tuned for endurance, quiet, persistent movement that continues long after other creatures are forced to stop. In that sense, the human body may be less like a powerful engine designed for sudden bursts of speed and more like a machine designed to keep moving steadily across the landscape, conserving energy while covering remarkable distances one patient step at a time. When we compare this ancient pattern of human movement with modern life, a strange contrast appears. For most of human history, movement was unavoidable. It was woven into every part of daily survival. If people needed something essential, they had to travel to reach it. Walking was not a choice. It was simply the natural rhythm of life. But the modern world has changed that rhythm dramatically. Today, many people wake up and walk only a few steps from their bed to another room. Transportation happens inside vehicles. Work often happens while sitting at a desk. Food arrives through stores, delivery systems, or machines that require almost no physical effort. Entire days can pass with very little movement at all. From a technological perspective, this seems like a great success. Human ingenuity has created systems that reduce physical labor and increase comfort. But from a biological perspective, something unusual has happened. The environment surrounding the human body has changed much faster than the body itself. Evolution works slowly. It requires thousands or even millions of years to significantly reshape the structure of a species. The modern environment, however, transformed in only a few centuries, and in some cases only a few decades. The result is a mismatch between the body's expectations and the environment it now inhabits. The human body still carries the biological systems that evolved for a life filled with regular movement. Muscles expect to contract and support the body through motion. Joints expect to shift weight repeatedly during walking. The cardiovascular system expects steady activity that keeps blood circulating through the body. When these systems are used regularly, they remain strong and coordinated. But when movement becomes rare, the body begins to adjust in the opposite direction. Muscles weaken because they are not required to produce force. Bones gradually lose density when they are not exposed to regular loading. Joints stiffen when they remain in the same position for long periods. Even metabolism changes when energy expenditure becomes consistently low. These changes do not happen because the body is malfunctioning. In fact, they occur because the body is extremely adaptable. The human body constantly modifies itself based on the demands placed upon it. If movement disappears from daily life, the body gradually reorganizes itself to match that reduced demand. In a sense, the body becomes efficient at inactivity. But this efficiency comes with consequences. Systems that evolve to function during regular movement no longer receive the signals they expect. Blood circulation becomes less dynamic. Muscles that stabilize posture become weaker. Energy balance shifts because the body is burning fewer calories. This is one reason why modern societies often feel the need to recreate movement artificially. Gyms, fitness programs, and structured exercise routines attempt to reintroduce the physical demands that daily life once provided automatically. Instead of walking across landscapes to gather resources, people now step onto treadmills. Instead of carrying objects through long distances, they lift weights designed specifically to challenge their muscles. These activities can certainly improve strength and health, but they highlight something interesting. They are attempts to simulate the natural movement patterns that were once built into everyday human existence. Walking, however, requires no special equipment, no complicated instructions, and no artificial environment. It is simply the most basic form of movement the body knows how to perform. When people walk regularly, many of the body's systems quietly reactivate. Muscles engage to stabilize the legs and hips. Joints move through their natural range. The heart and lungs work slightly harder to support the movement. None of this happens with dramatic intensity. Walking rarely feels extreme or exhausting, but its power lies in repetition and consistency. The body experiences a familiar signal repeated step after step, reminding it of the type of activity it evolved to perform throughout human history. Walking does not only influence muscles and bones, it also appears to influence the brain in ways that scientists are still trying to fully understand. At first, this may seem surprising. After all, walking is a physical activity involving the legs and the movement of the body through space. But the brain is deeply connected to every movement the body performs, and changes in movement patterns can influence how the brain functions. One of the most interesting observations is that many thinkers throughout history relied heavily on walking while working through ideas. The theoretical physicist Albert Einstein was known to take long walks while thinking about scientific problems. The naturalist Charles Darwin had a path near his home where he walked repeatedly while developing his theories about evolution. The philosopher Friedrich Nietzsche once suggested that the best thoughts occur while walking. These examples do not prove that walking directly causes creative thinking, but they raise an interesting question. Why might a simple activity like walking seem to help the mind process ideas more clearly? One possibility involves rhythm. Walking produces a very regular pattern of motion. One foot moves forward, then the other. The body shifts its weight from side to side in a predictable sequence. This rhythm continues step after step, often for long periods of time. The brain itself operates through patterns of electrical activity. Billions of neurons communicate with one another using rhythmic signals. Some scientists suspect that the rhythmic movement of walking may help organize or stabilize certain patterns of neural activity. The steady alternation between left and right steps might encourage coordination between different regions of the brain. Another possibility involves blood circulation. The brain requires a continuous supply of oxygen and nutrients to function effectively. When the body moves, the heart pumps blood slightly faster, increasing circulation throughout the body and the brain. Walking provides this increase in blood flow without placing the body under extreme stress. More intense activities like sprinting or heavy lifting can push the body into a high stress state where breathing becomes rapid and muscles demand large amounts of energy. Walking, by contrast, increases circulation while keeping the body relatively calm. This balanced state may create favorable conditions for thinking and problem solving. There is also a psychological aspect to consider. Walking often places a person in an environment that changes gradually. The landscape moves slowly past. New sights and sounds appear while the body continues moving forward. This gentle variation may keep the brain engaged without overwhelming it. When people remain completely still for long periods, their attention may drift or become unfocused. But when they walk, their senses remain lightly active. The brain monitors the ground, the surroundings, and the rhythm of movement, all while still leaving room for thoughts to develop in the background. Despite these ideas, scientists still do not fully understand all the ways walking influences the brain. Human cognition is an incredibly complex system, and many factors contribute to creativity, memory, and mental clarity. What we do know is that the brain evolved within a body that moved frequently through the environment. For most of human history, thinking rarely occurred while sitting motionless in a chair. Instead, ideas developed during movement, while traveling across landscapes, searching for food, or exploring unfamiliar territory. The human mind and the human body did not evolve as separate systems. They evolved together. When the body moves in the ways it evolved to move, the brain may also enter patterns of activity that feel natural and productive. Walking, in this sense, might not only move the body through space, it may also guide the mind through its own landscape of thoughts, one quiet step at a time. Walking is an activity so simple that it is easy to overlook, yet its simplicity is part of its profound significance. Modern society often emphasizes intense exercise, extreme sports, or highly structured fitness routines. People measure progress in miles run per hour, weights lifted, or calories burned, assuming that more intense effort must produce better results. But evolution rarely works by producing extremes. It favors efficiency, stability, and adaptability. In the case of humans, the simplest and most consistent form of movement, walking, may actually be the most fundamental. Walking is quiet and steady. It rarely produces exhaustion. It does not require specialized equipment, elaborate planning, or intense bursts of energy. Yet when performed consistently, it engages the body in ways that other forms of activity cannot replicate. Muscles contract and stretch in coordinated patterns. Tendons store and release energy. Joints move repeatedly through their natural ranges of motion. Even the cardiovascular system adjusts to support sustained activity without overtaxing the body. Over time, this low-intensity, high-consistency movement maintains and strengthens the body's foundational systems. One remarkable aspect of walking is its universality. All humans can walk. It does not depend on exceptional strength, speed, or specialized training. From the moment children learn to walk, the body is programmed to take steps, transfer weight, and balance efficiently. This innate capability reveals how deeply walking is embedded in human biology. The nervous system, muscles, tendons, and bones all cooperate in a way that appears optimized for continuous upright motion. Even subtle structures such as the curvature of the spine, the arches of the feet, and the alignment of the hips seem adapted specifically to support long-distance, low-intensity movement. Walking also integrates multiple systems simultaneously. While muscles and bones handle mechanical support and propulsion, the cardiovascular system delivers oxygen and the nervous system coordinates balance, rhythm, and sensory feedback. These systems interact seamlessly during walking in a way that mirrors the body's original evolutionary environment. Each step reinforces coordination, circulation, and energy efficiency, maintaining the body's internal balance without the dramatic strain of extreme exercise. The philosophical elegance of walking lies in its repetition. The step-by-step pattern is consistent, predictable, and unhurried. Unlike high-intensity movement, which stresses the body episodically, walking maintains continuous engagement. The body does not experience sudden peaks of force or extreme fatigue. Instead, it settles into a rhythm that the entire system recognizes and responds to. This rhythm may even extend beyond the purely physical. Evidence suggests that consistent walking influences the mind, supporting creativity, memory, and mental clarity. The body and mind evolved together in a world where walking was the dominant form of movement. And this activity may still provide signals that the brain interprets as natural and healthy. Walking's simplicity does not diminish its power. In fact, it is the very simplicity that allows it to activate fundamental processes without risk of overstress. While modern exercise often focuses on dramatic results, walking works quietly in the background, maintaining the body's systems in a balanced state. It teaches the body economy and resilience, enabling sustained activity over time rather than short, exhausting bursts. It is an exercise that does not compete with evolution, it follows it, engaging the body in the movement patterns that shaped it for hundreds of thousands of years. Ultimately, walking may be the most profound example of how the simplest actions often have the greatest impact. While extreme training and high-intensity workouts are useful in certain contexts, walking is the movement around which the human body was built. Its power lies not in spectacle, but in consistency, efficiency, and harmony with the evolutionary design of the human system. In this sense, walking is not just exercise, it is the quiet rhythm that maintains and sustains the human body step by step, moment by moment.